Hello students, this is Harish Konda. Welcome to my channel, the Chemistry Classroom. Today we are going to discuss about the chemical properties of alkenes. How they undergo in chemical reactions, now we discuss. The alkenes are unsaturated hydrocarbon compounds. What they are? Unsaturated hydrocarbon compounds. They are having double bond. So for example, say the ethene compound we discuss, the compound is ethene. So here it's C2H4. How it is undergoes in chemical reactions, now we discuss. So because of unsaturation, so here the double bond, the pi bond involves in chemical reactions. Why? Because here you observe in these bonds, here we have two type of bonds. The one they are sigma bonds and then it is pi bond. So here the carbon in between carbon atoms we are having pi bond. So the pi bond is very weak when you compare with the sigma bonds. So the pi bond is must broken and the pi bond is involved in chemical reaction. So the pi bond is broken and here the two atoms are added to the carbon atoms. So automatically the compound is formed. So what it is called addition reaction. So for double bond, so what you are doing here, I am adding two atoms to both carbon atoms which they are involved in pi bond. So the reactions are called addition reactions. So generally in the addition reactions, the alkene compounds will undergo in two type of addition reactions. The one is called free radical addition reactions. The second is called electrophilic addition reactions. Here the alkene compounds will undergo in two type of reactions. The one is called free radical addition reaction. The second is called electrophilic addition reaction. So how the free radical addition reaction will occur? How the electrophilic addition reaction will occur? With the examples one by one we discuss. Here the compounds are unsaturated compounds. The pi bond is involved in chemical reaction. So by removing a pi bond, the two atoms are added to two carbons. So these reactions are called addition reactions. Here we are getting two type of addition reactions. The one is called free radical addition reaction. The second is called electrophilic addition reaction. If free radicals are involved in addition reaction, that is called free radical addition reaction. So in the addition, very first the electrophile is added, after followed by nucleophile. That type of reactions are called electrophilic addition reactions. So we have to add two atoms. The two radicals we have to add, but in that first one electrophile is added, after followed by nucleophile is added. So this reaction is called electrophilic addition reaction. So one by one we discuss. Very first we discuss about free radical addition reaction. So how they are involved, now you see the mechanism also we discuss. So very first the free radical addition reaction I am discussing. So for alkene compound, I am taking the example that is ethene compound. So this ethene compound I am reacting with hydrogen. In the presence of nickel, platinum, palladium, whatever you take, the hydrogen is added to the alkene compound to form the saturated compound. It is alkane compound is formed. Why? Because it is alkene C2H4. For this C2H4, what I am adding? The hydrogen I am adding. So what you are forming, it is C2H6. That alkane you are forming. The saturated alkane you are forming. This reaction is free radical addition reaction. So why? Because this homoatomic molecule is reacted with alkene compound. So what it is reacted? Homoatomic molecule. When it is homoatomic molecule, these two hydrogens are involved in covalent bond. These two are having the same electronegativity. Here the electronegativity is same. So these electrons are pulled towards two hydrogens and it is equally cleavated. The bond is equally cleavated. It is called homolytic cleavage. How they are cleavated? Homolytically. So what you are forming, you observe here one electron goes to hydrogen and another one electron goes to another hydrogen. So what you are forming? Two free radicals you are forming. They, the hydrogen, when it is reacted with the hydrogen is homoatomic molecule. The two hydrogens are equal in electronegative. So the electrons are moved towards the hydrogens. So the each hydrogen is getting one electron, one free radical. When free radicals are formed, in the alkene also, what the cleavage you have to get? That's homolytic only. So here also the pi bond is cleavated homolytically. So here also we are forming the free radicals. How you see here? The alkene compound, you see this bond homolytically cleavage. Why? Because here the free radicals are reacting. So here also the bond is cleavated homolytically. So what you are forming, you see here the alkene with free radicals. These two carbons are having free radicals. So here the first carbon is having one electron. Why? Because the pi bond is cleavated homolytically. The carbon is getting one electron. The second carbon also getting one electron. Why? Because the attacking species are free radicals. So the free radicals are reacting. So in pi bond also it is homolytically cleavated. Here the carbons are getting single electrons, that is free radicals it is formed. These two free radicals are reacted with two hydrogen free radicals. So here the first hydrogen free radical is reacting with carbon, second hydrogen free radical also reacting with carbon, and what you are forming? One new bond you are forming in between the carbon and hydrogen. So here the new bond is formed. So between the carbon and hydrogen. So overallly, what happened here? The two hydrogens are added to the alkene compound. That's why it is called addition reaction. In this addition reaction, what they are involved? The free radicals are involved. So that's why it is called free radical addition reaction. Here hydrogens are added. That's why the reaction is called hydrogenation reaction. When the alkenes are getting reacted with hydrogen, so what you are forming, it is alkane. This reaction is free radical addition reaction. In the hydrogen you are getting two free radicals. The two free radicals, when they are reacting with alkene, in the alkene also the pi bond is cleavated homolytically. The two carbons are getting two free radicals. The two free radicals are reacting with two hydrogens to form alkane compound. It is a hydrogenation free radical addition reaction. At the same time, one more reaction also we get the example. So for example, I am reacting with chlorine or halogen. So the halogen is reacted in the presence of CCl4, carbon tetrachloride. The carbon tetrachloride is the solvent. In the presence of carbon tetrachloride, the chlorine is reacting with alkene compound. So what is reacting? It is alkene, that is C double bond C. So here what happened? The chlorine is the same electronegative atoms, the both are same electronegative. So here also the bond is cleavated homolytically. The electrons are moved towards one chlorine and second chlorine. What you are getting here, you see the chlorine free radicals you are getting. How many? There is two chlorine free radicals you are formed. When chlorine free radicals are formed, so here also the bond is cleavated homolytically. So what you are forming, you see, the carbon is getting one electron. At the same time, the second carbon also getting one electron. So here you see the carbon is getting one electron. The second carbon also getting one electron. These two electrons are reacted with two chlorine atoms. So here the chlorine is getting one electron. The second chlorine also one electron. One new bond is formed between the two chlorines. So what happened, you see? So here the two chlorines are bonded with two new bonds. So here free radicals are involved to add this reaction. That's why it is called free radical addition reaction. So here that is hydrogenation. Here it is halogenation. In the halogens, the iodines are added freely, then compare with the bromine, then compare with the chlorine, then compare with the fluorine. So here the ions are easily added to the compound. Then bromine is added, then chlorine, then fluorine. These reactions are called free radical addition reactions. With these reactions, one more type of reaction also you will face, that is called electrophilic addition reaction. How the electrophile is added to the alkene compounds. Now we observe. So why it is electrophilic? Why that added electrophile first added to the alkene? Now we discuss. That is second type of reactions, electrophilic addition reactions. So here with example we will discuss. So the electrophilic addition reactions we are going to discuss. So here in between carbon and carbon we have the pi bond. Pi bond means the free electrons, the p orbital electrons, they are laterally overlapped to form the pi bond. So here when alkene is formed, here the alkene compound, so in the alkene we have one pi bond, the free electrons, p orbital electrons which is not participated in hybridization, the two electrons are laterally overlapped to form the pi bond. The pi bond is nothing but one electron cloud. Why? Because these two electrons are completely, they are sharing with these two carbons. Laterally they are sharing. So when they are laterally they are sharing, the electrons are negatively charged. So here one cloud you are forming. What is the cloud? It is called pi cloud. What it is? Pi cloud. Pi cloud is negative charged one. When pi cloud is negative charged one, so if it is going to react with one compound heteroatomic molecule, what it is? Heteroatomic molecule will take HX. So why? Because one hydrogen and halogen I am taking, the hydrogen halide I am taking, this is heteroatomic molecule. Where it is heteroatomic molecule, in this two, hydrogen and halogen, so we have the electronegativity difference. In this two, the hydrogen is less electronegative, the halogen is high electronegative, so the electrons are moved towards the halogen. When the electrons are moved towards the halogen is getting negative and the hydrogen is getting positive charge. So here you observe, when the alkene compound, it is reacting with heteroatomic molecule. So here in the heteroatomic molecule, we are having the difference between the two atoms, the electronegativity difference we have. The hydrogen is less electronegative, the halogen is high electronegative. So the electrons are moved towards the halogen. When the electrons are moved towards the halogen is getting negative and the hydrogen is getting positive. So in this hydrohalides compound, the hydrogen is positively charged, the halogen is negatively charged. So in the alkene, what you have? The pi cloud you have. The pi cloud is having negative charge. Why? Because the electron cloud it is. The electrons are negatively charged. So the pi cloud is negatively charged. So when this compound is going to attack with alkene, in these two ions, the H plus ion, that is electrophile, first attracted towards the pi bond. So here what you are getting? One middle intermediate compound you are forming. What is the intermediate? Now you are able to see. So here you see the H plus ion is moving towards the pi cloud. So automatically these two carbons are getting attracted with this H plus ion. Why? Because the pi cloud is attracted the H plus ion. When the pi cloud is attracted the H plus ion, here you are getting one intermediate. The unstable intermediate you are forming. This unstable intermediate, after getting the reaction, so the hydrogen is added to one carbon. So automatically what happened you see? So the hydrogen is added to the first carbon. So the hydrogen is added to the first carbon. Then automatically the second carbon is getting positive charge. Why? Because the H plus is added to the carbon. When it is added, the total pi cloud is moved towards one carbon. Here you see the pi cloud. The pi cloud is completely moving towards one carbon. So when the carbon is moved with the pi cloud, the carbon is getting negative charge and the carbon is getting positive charge. So the H plus ion is going to attack with one carbon. Initially we are getting one intermediate, the unstable intermediate. The pi cloud electrons are completely moved towards one carbon. That carbon is getting negative, opposite carbon is getting positive. So the H plus ion is added to one carbon. So opposite carbon is getting positive charge. When it is positive charge, here the halogen is having the negative charge. So this halogen is attracted with this carbon. So automatically the halogen is added to this carbon. And what you are forming, you see, the compound. So here you are forming two bonds. The one hydrogen is added to one carbon and the halogen is added to the another carbon. Overallly, the HX is added to the compound. So that reaction is called addition reaction. In that addition reaction, very firstly, H plus ion is added. That means electrophile is added, after followed by nucleophile is added. So that's why the reaction is called electrophilic addition reaction. Generally, the alkenes will undergo in two type of reactions. One is free radical addition reaction. The second is electrophilic addition reaction. I am repeating, in the alkene, so we have pi cloud. Why? Because the pi bond is formed in between two carbons. The carbons are having one pi cloud. When HX, the heteroatomic molecule is going to add with alkene. So in the HX, the electronegativity difference you have. The electrons are moving towards the halogen. The halogen is getting negative and the hydrogen is getting positive. So H plus ion is attracted by the pi cloud. So H plus ion is going to add with one carbon. So the opposite carbon is getting positive charge. The negative ion, that is nucleophile, is going to add with that carbon. And finally you are getting the additional compound. Additional reaction compound you are getting. So this reaction is called electrophilic addition reaction. So we have to form one electrophile and nucleophile. The electrophile is first added and the second nucleophile is added. So that's why you are forming the addition reaction compound. So generally when you take the ethene compound, the two carbons, if you add halogen to the first carbon or if you add the halogen to the second carbon, you are not going to get any difference. But when it is the compound, if it is, for example, this compound you take, it is propene compound. For the example, the halogen is added to the first carbon. So what you are forming? 1-chloroalkane you are forming. Halogen is added to the second carbon. You are getting 2-halo compound you are forming. So here we are getting different compounds. The 1-halo or 2-halo. So what is the major compound? What is the minor compound? We have to discuss. So to get that one, so we have one principle, one rule we have, that is called Markovnikov rule. As per Markovnikov rule, the reaction is conducted and what the major product we are going to get. Next we also discuss. So that is one. So all of you, please keep on watching my videos. It is very useful to you. And don't forget, like, share, comment and subscribe. Don't forget to bell. Okay. Next video we will discuss about the Markovnikov and we have one reverse rule also. It is called anti-Markovnikov. That is called Karash effect. So these two rules we discuss in the next video. Okay. Thank you.